So a general minimization formulation is as follows. Now, you have seen this before, but we just write this once more. You have seen it for the Dirichlet problem, but a similar formulation can be written in a general case, and it's always like the one we had for the Dirichlet problem. We want to find the solution U in this Hilbert space V, such that f of U is the minimum value of f of phi, where phi is where we consider all phi in the Hilbert space V. So we have this equivalent formulation, or the same formulation as this, that f of U is less than f of phi for all phi in this Hilbert space. And as before, this f of phi is equal to half a of phi minus L of phi. So that's some general minimum formulation, or a minimal energy formulation, if you like. A general weak formulation is exactly as for the Dirichlet problem and for the Neumann problem, which we considered earlier for the Poisson problem. It takes this form. So we call this a weak formulation, and in the parenthesis here we have used capital V to symbolize weak formulation. We have some theorem which is one of the most important theorem in the theory which we are considering this week, and this theorem is called Lax-Milgram lemma, if you like. Someone call it a theorem, and it's named by the famous mathematician Peter Lax. Peter Lax he is also a famous physicist. He participated, for example, in the Manhattan project where the nuclear bomb was invented. This Lax-Milgram lemma or theorem says following: if the conditions 2, 3, and 4 are satisfied, then there exists a unique solution of the problem W. Let's just remind you about that this is the general weak formulation. So if conditions 2, 3, and 4 are satisfied, then we always will have a unique solution, and we will not prove this. Moreover, if the condition 1, 2, 3, and 4 are satisfied, then the minimum formulation and the weak formulation are equivalent. That is, there exists some solution U satisfying the minimum formulation. If this satisfies the minimum formulation, then it will also satisfy the weak formulation, and vice versa. So these are two important theorems related to the modern theory.